4.5 part 3. So this is Spearman's rank order test. So if we go back to the inferential statistics, it's a correlational test and it's non-parametric. So the formula up here, so it is 1 take away 6 times the sum of the squared differences between the rank over the number of participants, brackets number of participants squared, take away 1. So this is a much more simple formula compared to Pearson's. So the sum of the squared differences between the ranks. So for this test, you have two sets of data. So I have my static sprint in this column and I have flying sprint in this column. I have then ranked them in order, so in these columns here, from the lowest being 1 to the highest being 10. I then go along, so the difference between the rank of the top one, which is 5, and the rank of this one, which is 2, would be 3. So that goes into this column here, which is the difference between the rank. So I do that for all of them. Then next, I have the difference between the ranks squared. So obviously this was 3 in here, so this one here will be 9. So I do that for all of them. I will then add them all up. So this gives me the sum of the differences squared, which goes up here. So for my results, it's 150.5. So I will then do 6 times 150.5 over the number of participants, which is 10. In here, it's number of participants squared, which will give me 100, take away 1. So once this has all been calculated, I have my result in here, and I have to do 1 take away this answer. So my calculated R value is 0.088. So just like before, I have a critical values table up here. So we have to find the DF again, which is calculated the same. So number of participants, take away 2. Number of participants being 10. So take away 2 is 8. So we then go down to 8 on this column here. And then our significance level is 0.05. So we go along. So the critical value that we gain from this is 0.74. So if my calculated value, which is 0.088, is higher than the critical value, there is a significant relationship. But if the calculated value is lower than the critical value, there is not a significant relationship. So my 0.088, which was my calculated value, is lower than 0.74, meaning there is no significant relationship or correlation between these data sets. So moving on to the next test, which is the dependent t-test. So if we go back to the inferential statistics, the dependent t-test, so it's a difference test. There's only one factor. Now, dependent means if you have the same participants for your before and after test, essentially. So we go down to the same. It's a parametric test, so it's down here. So, sorry, going back to the dependent t-test. So with this formula, up here, you have the sum of the difference over the square root, excuse me, the square root of the number of paired scores times by the sum of the differences squared, take away the sum of differences squared, divided by the number of participants, take away 1. So the sum of the differences is worked out by, you have your two sets of results, so you'll have a pre-test and a post-test. So for example, participant 1 in their pre-sit and reach test got 25 centimetres, in their post-sit and reach test they got 28. The difference between this is 3. So to work out the sum of the differences, you add all of this column up here to get the sum of differences, which in my case was 40. Now, just like in the Pearson's test, you have the sum of the differences squared and the sum of the differences squared. However, the sum of differences squared in the first bit, which you're timesing by the number of participants, is calculated by having this column squared to get this column. So as stated, the first difference was 3, so that was between 25 and 28. So that squared is 9. So do that with all of these rows, get all of these, and you add them all up. So for mine it's 316. So I would times 316 by 6, which is the number of participants I have. Now for this one, which is the sum of the differences squared. So I have sum of differences. So it's this column here before we square any of it, added all up together, which is 40 for me. I would then square 40 for this part here. Once you've done all of that, you will get a calculated t value. So mine is 5.199. Now, coming back over to the critical values table. So to find the DF, it's exactly the same number of participants. However, this time instead of taking away 2, we take away 1, which gives us 5. So we find 5 on this side here. We will go along to the level of significance for two-tailed to 0.05, and we'll link them up. So the critical value that I got was 2.571. So if my calculated value was higher than the critical value, there will be a significant difference. So my calculated value was much higher than the critical value, so there was a significant difference between these two tests. So the last test is the independent test. So coming back to this part, so it's a difference test. There's only one factor. Now it has different subjects. So the pre-testing and the post-testing will be conducted by different participants. We follow it down, it's a parametric test and it's the t-test in here. So going back to our data, so the formula up here, now this is quite a long formula. So on the top you have the mean value for group 1. So you have the two groups in here, so you'll add them all up and divide them by 10 to get your mean value, which is 1.76. You'll then take that away from the mean values of group 2. So coming down here, you have the square root of the standard deviation for group 1 squared divided by the number of participants in group 1. And then you add that by the standard deviation of group 2 divided by the number of participants. So my standard deviation for group 1 was 0.2 and my standard deviation for group 2 was 0.87. So once that's all been worked out, you will get a calculated t-value. So my calculated t-value was 0.43. Just like before, you have a critical value table. This DF is a bit different. So you have number of participants in group 1, which is 10. Add the number of participants in group 2, which was also 10. And then you then take away the 2. So my DF is 18. So you then go down and find 18 here. We're looking at the level of significance for two-tailed test, which is this bottom bit here. And we're going to 0.05 again, which is the middle column. So the critical value I had was 2.101. So if the calculated value is higher than the critical value, there is a significant difference. However, if the calculated value is lower than the critical value, there is no significant difference. As my 0.43 is lower than 2.101, there is no significant difference in this data here.